Math 8. Today we're going to continue our discussion of scatter plots and data with trend lines as we discussed or started last week. And so we're going to keep looking at scatter plots and stuff like that today and learn a couple more things about them and what to look for. So I just want to start by reordering my slides. So I'm going to go back to the first slide. And I'm not sure why I'm still in a bad order here, but we're going to start with that one and end with that one. So we're going to start here. I want you to think about how are these scatter plots alike and how are they different. So what makes each one unique, and is there anything weird about any of them? Is there any patterns you notice? So just take a minute and pause yourself and think about what you see while I add in text boxes. So the first thing I'm going to say about scatter plot A is that the data appears to follow a pretty steady downward trend. Data follows a clear downward trend. And in that case, you would actually say that the trend line has a negative association or negative slope. We calculated slopes of lines a lot in the past. We're going to consider it again, and we're going to talk about what that slope tells us. So just be mindful of that. So graph A, trend line has a very negative association. The points are pretty close to the line. Nothing crazy is happening. It's pretty hard to deny that. Scatter plot B seems to have, it seems to go up slowly over time. So it has what we call a positive association or positive slope. That was not the right color. But I also noticed here in scatter plot B, there appear to be two different clusters of data, or two different sets of data. And what I mean by that is I see sort of this upper chunk up here, and I also kind of see this lower chunk down here, which is not exactly what you want, because that means there could be another variable at play here. So there could be something else. There could be something else affecting this relationship that makes me have one set of data here and another set of data down below. So maybe there's something else we could consider here. Maybe if we were talking about the diamonds in the past example, where the relationship between their carats versus their price, maybe there's another variable like the shape of the diamond. A certain shaped diamond might be worth more, and or something like that, or a different cut. And this graph again has no labels, but maybe it's maybe it could be prices at a general grocery store, I don't know, a Walmart or something. Then maybe more a Stu Leonard's up here, a more high-end grocery store or something like that. So who knows? Maybe there's two different things at play there. In graph C, we seem to have two different sets of data. One goes up and the other goes down. And again, you might have looked at these three graphs and thought of three totally different things. But I'm just sort of showing you what I see. And what I saw for graph C is, again, something you don't love to see in scatter plots. And I am just messing up the screen here. I don't really love to see that the data kind of does two separate things. It's got an upper path and it's got a lower path. And then graph D, it all kind of goes in one direction. But again, I've got two little clumps. I got this first clump where x is between like 1 and 5, another clump where the x is like more than 12. And there's absolutely no data right here in the middle. And like if I want to draw a trend line through some of this data, I could for sure draw like this trend line seems to fit the data okay. But also like I'm not super happy with it because I think I could draw a couple better lines. Like I think, can I draw this line? I think if I like this, I think the end of this data for sure has a, I can't draw lines. I'm doing bad at this. Okay. Give me a line. I give up. Anyway, so this data here seems to be much flatter than this data up here. Like I seem to have like a lot more scatter in this first set of data up here, whereas down towards the end it seems to follow a different trend. So we actually have a vocab word called clusters, and a cluster is basically, it's a group of data points that seem to be separate from the rest of the data. It's not really an outlier, but like it's like you can tell that this group of data doesn't quite fit in with the rest of it, or maybe there's two different trends. Like in my graph I have this clump of data here, and it's kind of different than this clump of data over here. Or like maybe they do follow the same trend, but it's literally just a clump of points. Or like a hotspot, or like it's like a neighborhood in like a town, like a neighborhood that there's a cluster of houses there. Maybe the main road doesn't have as many on it. I'm sure some of you live in neighborhoods where it's like there's a lot of houses in your street, but then there's like a longer street to get there that there's like nothing on. Or maybe vice versa. Maybe you know that like your street is sort of quietish, but the next street over has a lot of houses on it. So cluster is just, it's really just what it sounds and what it looks like. Does it look like a clump of things all close together? Like a cluster of grapes, they're all together on the vine. Or like a cluster of bananas, they're all like right next to each other. But like fruits that like don't necessarily have clusters are like oranges and apples. They're just like there on a tree. They're just alone. Hopefully that visualization helped. Okay, so really the main point of today is to look at, we have positive trends. So in the scatter plot here, we see that as tax payments, let me actually add some text boxes here. So in this graph, we can see that the x-axis has tax payments. So the number of thousands of, the number of thousands of tax payments, and the y measures the annual income. So it's comparing people's well, something about tax payments. I don't have this actual graph's context. Comparing the thousands of tax payments, or how many, I guess it's how many people pay that much tax, compared to the annual income in thousands. So what my graph is really showing me here is there's a positive trend. So the positive trend means as the number of tax payments increases, the annual income also increases. So when you see an increase in one, you expect to see an increase in the other. So that's like what our positive slope, our positive association means. So an increase of one means an increase in the other. And we're going to go back to talking about slope here while we continue this, while we talk about this graph as well. Because we want to make sure you remember how to calculate slope, which I'm sure has been at the forefront of your minds for the past 3 months. So I'm going to pick points on my line. So let's see, to calculate slope, I'm going to share this with you obviously because I want you to know how to do it. To calculate slope, And really when I say to calculate slope, you could even say like to figure out the rate of change or yearly growth or annual growth or like just the growth in general. I want you being like, oh, here we go, slope, something else useless. It could be like, it's clearly a realistic concept even though I don't know what the graph is telling us. So to calculate slope, identify 2 points and identify the vertical and horizontal change, or the rise over run. So I'm going to pick that point right there, and I guess I'll color it like green, because why not? And I'll pick another point and I'll color it pink, because why not? And I picked this point here because I noticed it was right on 20 and 2. I'm going to look for another one. I'm going to look for a faraway point. This one's not bad. And notice I'm going for points on the line. Ooh, this one's good. I like this one. Right here. Now, this one happens to be a data point up here. Does not have to be a data point. Like that green point, notice, was not a data point. No data is there. But the trend line is there, because that's what I'm measuring, the trend line here, not the data. So in order to figure out my slope, I need to make sure that I'm doing my vertical change and my horizontal change. So I want to figure out how much up did I go and how much to the side did I go. So let's see, I drew my triangle. Remember drawing those triangles? This year is really coming full circle. I wish we were all here to enjoy it together. This unit could be so much better in person in the classroom. So I noticed that horizontally I went from 20 to 100, which is the change of 80. And then on my y-axis, my annual income went from 2 to 12. Is a change of 10. So now, do you remember how I calculate slope from here? That's right, I have to divide them. I have to do the vertical divided by horizontal. So then, let's see, I'll take one more text box. Slope is vertical divided by horizontal. Oh, I'm capitalizing everything. So then I could say my slope is 10 divided by 80, or 1/8. So as my tax payments increase by 8, my annual income is going up by 1. Now, I would love to have more context of this graph, but this is what we got to work with. So that's just the calculating slope lesson. So basically here on our next one, we notice a negative trend. So when I calculate slope here, I would get a negative slope of my graph. And a negative slope is basically just telling me that, this one I love the context, it makes so much more sense, and I love doing car projects. As the age of the car increases, the resale value, aka how much money can you sell it for, decreases. I don't know why I capitalized resale. So we see that there is a negative trend, because as your car gets older and older and older, you can sell it for less and less. And that's true for most cars, unless they're collectibles or antiques. Most cars, the older they are, the less money they are worth. So this is a negative trend because as one increases, the other decreases. So if I increase the value, or if I find a more expensive car, it's likely to be a newer car or a car with less age. And if I have an older car, it is likely to have a lower value. So that is what we are dealing with here. And to calculate slope, again, it's still the vertical divided by horizontal. I'm going to put that into a nice sentence for us. Let's see, I'm going to pick two nice points on our graph to calculate some slope. So let's see. Where's a good point? This is like, this is a good one right here. I like this one. That's 6, 4. It's like 2 and 9. That's fine. This one right here is like 2, 9. I'm just going to go with it. So let's see. Let's insert some lines. And I'll take an art project here. Where's my line? I probably went by it already. So again, I'm looking to see what my vertical and horizontal, come on, dude, change is in this case. Seriously? There we go. Good grief. Scale from 1 to 10. How bad is Mr. Roboto at computers? Just kidding. I'm normally okay. So again, I redrew my triangle just to sort of keep an eye on where everything is. So my vertical change over here, it went, so vertical is from, let's see, it started at 4 to 9. The change is 5. And then my horizontal change, let's see, it started at 2. The x value started at 2 and went to 6. So the change is 4. Right, yes. So my slope is 5 or 4 in this case, which is 1.25. So I can say, as an intelligent person, or not intelligent person, as somebody who's using the information that they have in front of them, as a car's age increases by 1 year, the resale value, what happens to the resale value for a year? Decreases by, let's see, $1.25 thousand. So again, this is a general trend, a noticing of things. Notice this red line isn't really close to a lot of the data. And as you'll learn about in Algebra 1, there's a different name for data that sort of follows this trend here. If you talk to me Algebra 1, because they did a project about resale values of cars, and I would love to do that with you guys if we were in school. But I don't know how I'm going to make it work over online. It's probably not going to work. And some of you will probably be very happy about that because it's kind of a lot of work. It's a little bit difficult, but it's fun. And it's interesting to see. Anyway, so we see that the age went up 4 years and the value went from $9,000 to $4,000. So it's averaging its decrease by $1.25 thousand. Or I could say $1,250. That's $1.25 thousand. Okay, so that's our scatter plot stuff. This scatter plot has no trend, no correlation at all. It's just nothing's really going up and down over time. It's just a horizontal line is really just no trend, no pattern. So we have some data that forms clusters. This is a pretty straightforward thing to discuss. The data here is in 2 clusters very clearly. So Old Faithful is a geyser in Yellowstone National Park. And basically what the scatter plot is showing you is there's a positive correlation here. The eruption duration, so how long it takes to erupt. Sort of a geyser, it's like a volcano with water, but it's like smaller. You should look it up, it's pretty cool. So the longer that the duration lasts, so the longer it blows up water for, the longer the waiting time between the eruptions. So there's a positive correlation there. But there's also clusters. So typically, what Old Faithful will do is it'll have a small eruption with a small wait time between the eruptions, so maybe a couple short ones, or it'll have longer eruptions that are like 4 to 5 minutes and then go about 80 minutes without having an eruption time. So there's really like not a whole lot of data in the middle. There's like these short eruption times and these big eruption times. It's kind of interesting to see that. And then over here in this data, this graph has very unhelpful labels, but there's clusters of data here too. There's just 2 chunks of data. So that's what a cluster is. And then just to sort of wrap up, I guess, I'm going to be able to interpret what slopes tell us about trend lines. So this one actually gives us the equation. This is actually about our weights of diamonds and their price. This trend line equation tells us, let's see, y equals mx plus b is my format, where m is my slope. So I'm thinking, all right, let's see, I'll put all this highlighting in this nice blue color. It was not what I wanted, whatever. Sorry, my cat just scared me. Sorry. Let's see if I can recover from that one. Okay, there's my slope, and my slope over there is, oh, I can't even highlight. Dang it. Whatever. So my slope is 5,520.619. So that's my slope. And basically that tells me the change, like the dollars per carat change. So basically if I add a carat to my diamond size, I expect to pay an extra $5,500 for that diamond, which is horrifying. Whatever. That's the way it is. So I'm expecting to see that increase. So yeah. And then that went down here again, the weight of a car versus fuel efficiency. We talked about these graphs last time. As that car got heavier, it got less fuel efficient. So as you increased your weight by a kilogram, you lost 0.01, a hundredth of a mile per gallon in efficiency, which seems pretty silly. So really what we could do is you could even write let's see, we could sort of scale these numbers up. Over 1, let's see, so that would be 1.1, negative 1.1 per 100 kilograms. Multiplied by 100. So I could say that, oh, I'm losing a mile per gallon for every 100 kilograms my car weighs. So if my car weighs 220 pounds more, it loses about a mile per gallon mileage. So there's that. Really, that's going over the top what we need for today, but just sort of to throw that into real context, because no one talks about hundredths of a mile per gallon, because that's just so ridiculous. And then basically you want to be able to fill in the blanks in these sentences. So for these data, as something increases, something else tends to increase. So which graph shows something increasing as something else increases? And that graph would be this one here, this diamonds one. So as the carat to the diamond increases, the price also tends to increase. And then for another one, as something increases, something else decreases. That would be this one up here. So as mileage increases, the price tends to decrease. And for the last one, must relate to this one, and I kind of see why, do not appear to be related. So not a positive or negative trend line shows that they're not really related. So the high temperature of the day versus the energy consumed are not really related. And that's just basically because, like, yeah, you might use more air conditioner on a hot day, but most people do not cook on a hot day. Or some people try to avoid cooking in their ovens on a hot day, or just whatever. So there's all sorts of different things at play. Okay, so that's pretty much our lesson for today. We talked about the scatters, looking at on graphs, like what a scatter, we talked about clusters on a graph, what a cluster is, and we talked about how to calculate slope up here. We talked about what a positive versus negative trend was, so hopefully this is helpful for you. Another quick exit slip today. We are almost done with our year, which is so sad. I wish we were doing stuff in the classroom to really round out June, but I miss you all. Good luck on your exits today, and enjoy your day off tomorrow. Please just make it fun and outside, and don't spend too much time on schoolwork.